Hi, everybody. My name is Kyle Prince, and I work for Dell EMC. I was going to talk a little bit about what we provide from an application standpoint for Splunk, and then a few different products we have that we think could help you guys a bit from an infrastructure standpoint. Just a little bit about who I am. So I work full-time for Dell EMC as an SE, but I'm also a Splunk architect and SE3 as well. Just moved to Sydney, Australia in August, so don't quite have an accent yet. We'll see how that goes. Got a bachelor's in computer science from, or computer engineering from University of Tennessee. There we go. Yeah, go Vols. Used to be a Dell EMC customer. From there we had around 300 VNX arrays across 200 different sites. Had Cisco MDS switching for both A and B fabrics on each of those, a data domain in the back end. And then on top of that, we had 4 main data centers that we had to keep that up with. We had a team of 3 to do that. So we had one guy whose job was just taking care of POP drives and then a few other different things. So you can see we're at scale. This kind of got to be a bit of a hassle and we needed some help. And actually Splunk was there to help us along the way. So former customer of Dell EMC both and Splunk, and saw huge value with it. So we got to be really excited to work here and have the opportunity to share from my experiences with that. Forward-looking statements. I don't think I'll make anything forward-looking, but if I do, don't believe it. Key takeaways. Just want to make sure that you know that Splunk is becoming a business-critical application. If the size of this conference hasn't shown the growth that Splunk has, take that as a note. We believe that an intelligent storage system can help add speed and resiliency to your Splunk deployment and maybe take care of a few problems you may be having now with alternative deployment styles. And then also having insights into your infrastructure is a key to success. The house is only as good as the foundation that is built upon it. Your Splunk deployment is only as resilient as the infrastructure underneath it. Just to level set on some Splunk storage recommendations, this comes from Splunk, but we are firm believers in it. This is also following the old storage deployment style, so this is not inclusive of Smart Store. If you do have questions about Smart Store, though, once we're done, please, anybody in the Dell EMC t-shirts or the peanut gallery over here, please come see us, and we're more than happy to share some of the things we're doing around that as well. But for hot warm, we typically see a lot of draw to flash, and the reason being it's just at the cost effectiveness of flash. It might as well go for it because the speed outweighs the cost. Cold you can do typically with a NAS platform or local block storage if you want. We have a wonderful product from a NAS platform that can massively scale out that we'll talk about in a bit. And then frozen, you can do NAS or object store, but if you've already paid for the ingestion of it into Splunk, why not just keep it in cold, and then you can search it without having to pay the penalty of the license without being able to search it. Let's go over what an intelligent storage system looks like. So this would be on our left side, would be servers that have a LUN served up to them. Across that is a SAN fabric. It can be fiber channel or iSCSI. In my particular case, we worked a lot in fiber channel fabrics. Within the storage system itself, though, you have 3 to 4 major components that you really need to be mindful of when you see performance interruptions. The first one being the front end. So that would be the ports that plug in to the SAN fabric of the front end of your storage array. Second part being the cache, and that is where your data will live in an intermediary area before it is flushed through your back end to your physical disks. Where you really see a lot of differentiation between major storage providers is the secret sauce in the caching and the destaging of the data out of cache into your physical disks. And that's where a lot of AI and machine learning has started to come into play across new platforms. But one thing to keep note of here is that your front-end cache and back-end are all different areas that can greatly increase or hinder your performance. And as a storage administrator, those are all key areas that you need to take a look at when you're having an application problem. Some good rules to follow for intelligent storage systems running Splunk. Multiple paths to the storage array are a must. And don't always assume that the guy before you or the girl before you did that correctly. We've stepped into a lot of major accounts, both as customer and Dell EMC employees, and seen where their tier 1 applications are just having one path to the storage array. And if that path went down, we would have a bad time. Also, one thing to keep in mind there as well is that not only to have multiple paths, but to have multiple paths across different engines from within your storage array. So that way you have the added resiliency of a path hitting a different engine. That way if an engine goes down, your paths to your other engines are still holding up just fine. When I was a customer, we kept the rule of having 4 paths for all applications, and then the typical speedier applications, we would do 8 different paths across as many engines as possible. And if you want to go deeper into that, again, come bug me later and we'll chat it out. Auto tiering is a really cool concept. It lets you store your data in different areas across different tiers of the back end of the storage array. Really neat concept, but for Splunk, in my opinion, turn it off. Just leave it in the SSD tier for your hot warm. Let Splunk handle the tiering of your data. It's really good at what it does. Don't overcomplicate it. When in doubt, SSD where you can. We really do see speed increases and cost per dollar benefits from SSDs versus 10K, 7K, 15K drives. Also be watchful of your cold queries. Your users and your search users can really start to abuse how they write searches, and you could have the best performant storage in the world, but if you have bad queries that are written or one user who's really causing the rest of the infrastructure to have a bad time, that can be poor benefits for you as well. So those would be some key areas that we looked at when we deployed Splunk to make sure that we did it well. Okay, so for hot warm data, we have a product called ExtremeIO. We used it as well, and it was a wonderful product for us. It's a massively scale out all-flash storage array. It can do over 1 million IOPS with sub-millisecond latency. It also has multiple engines as well, so again, zoning it out is very simple to do. And upgrades, every upgrade you do, you'll get more drives with new front ends, with new cache, so you're scaling linearly, so you're growing your capability of capacity and performance as well. If you do need the requirement of data at rest encryption, we can do that with data at rest encryption drives. And you can access this via Fiber Channel or iSCSI as well. One unique thing about ExtremeIO is that it does inline data reduction, so there's no garbage collection on the back end. So your data is coming in and it is being identified and reduced within the ExtremeIO as it's coming into and being written to disk. We have an app for that we used when I was a customer, so we're going to walk through what that would look like as well and identify some of those major components of an intelligent storage system, and then bring those back to Splunk and see what we could do. So right before we got up here, our storage director, Natalie, came up and said we needed to take a look at our new Horizon environment that we had deployed. So we went ahead and logged into Splunk. We have 2 different ExtremeIO arrays here. This is the same application for Splunk, but because we have multiple arrays, we were able to add them into one front end. So if you do have multiple ExtremeIO arrays, oh, you can't see it. Oh yeah, thanks Corey. Yeah, kind of good to see a demo if you're going to see it, right? How's that work for everybody? Yeah, good enough? Too much. A little bit easier, right? There we go. Okay, so we have 2 different clusters here. You can access a cluster through management itself of the IP address. What we require from within Splunk is an IP address of the cluster itself, a username, and a password. From our experiences, we recommend just setting up a separate Splunk admin for the array itself, and then provide those credentials to your Splunk admins through the TA. And if you have multiple arrays, you can provide multiple IPs, multiple usernames, multiple passwords, and get them all to show up in this simple interface. But for us, we stood up a Horizon environment from within our CEC ExtremeIO. So we went ahead and clicked into that. With an overall summary, you can see things like overall efficiency, data reduction ratios, dedupe ratios, as well as some thin provisioning. These lines up front are all just overall KPIs, things that we at Dell EMC thought were good for you as a storage administrator to provide to your application teams when you do have issues. one things that we really found useful was that the initiator summary that you're able to then just go ahead to connection state, see some are disconnected, and then go ahead and hand that off to somebody else. And now they have their workday set up to go ahead and clear those alerts from within Splunk and remediate those issues. This keypad is extremely touchy. You were right, yeah, no kidding. You can also dig into all these dashboards. So they're all very basic on the front end, but they provide an overall view. You can also dive deeper into these. So if we wanted to look at latency at a microsecond level, we can differentiate between read and write bandwidth and provide that overall up. And we can do that as an overall cluster all the way down to LUNs, targets, initiators, the whole gambit across the board. But let's go back. Our volume summary at the top, we found our Horizon LUN. We can go ahead and provide that and give that overall snapshot back to Natalie. Or we can dig deeper into read and write performance ratios. Wow, this keypad is touchy. But thanks to Splunk as well, we've got the standard export PDF built in where we can just go ahead and send that back to her. You can also have the alerts triggered within this. But one thing from my standpoint is I would prefer to keep the alerting at the array level itself. So your alerting of your storage array isn't going through Splunk, but it's rather coming from the array itself. So that's just one caveat I would keep in mind on that. From ExtremeIO overall, though, we do have overall summaries of cluster volume, initiators, and targets. So volumes being the LUNs or the disks that live on the array itself, initiators being the HBAs that are on the servers that are then logged into the targets of the array. We can look at overall performance, raw events, and then also just do a search of the ExtremeIO arrays from within the ExtremeIO app. So you are already blocking out all the extra data that's within your Splunk environment. Okay, so we'll move on to Isilon. Isilon is our forefront product for cold and frozen data right now. We also have another product about smart share that we can talk about, or smart storage that we can talk about later, but in the field we've used Isilon quite a bit, and if you can read the numbers on the side, you can see why we're pretty excited about it. It's a scale-out file system, so we can scale up to 68 petabytes in a single file system, single namespace, single cluster. And when we were customers, we didn't have a lot of time to rack and stack, install, migrate. So what we were able to do with this is just install a node, and on the front end of the keypad, push go, 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 add node, and Isilon would kick off jobs that would auto rebalance the storage in the back end, and then also apply it to front end smart connect policies that would auto balance the front end load of it as well. And then removing that was just as easy by going in and ejecting the node from the smart pool policy or the storage policy, and that node would start to flood the data off of it as a low-level job. So you could come back a couple days later and just pull the node right out of the rack, which seemed extremely effective for a team of 3 and 400 stores, right? Didn't have a lot of time. Oh, I thought that was for me, sorry. What else do we have? Yeah, auto balancing of nodes. This is a really fun product for cold buckets because you're able to scale out for your larger Splunk deployments, and your performance at scale doesn't have to suffer because you're adding performant nodes on the front end as well. So we'll go ahead and dive into that a bit. And I need to end show. So from within here, we can just slide right down to the Isilon app for enterprise. Same situation, we have 2 different Isilon clusters. One's in Sydney and one's in St. Louis, I believe. And then we just are able to add those in through multiple app add-ons and have it all appear under the same app. So your Isilon admin isn't having to change through multiple views to go ahead to see its different clusters. Overall, though, we have key things like code levels, number of nodes down, overall disk usage, external network throughput. You can see file system throughput over time, so whether you're being read or data's coming out or data's going in. You can also have your events by summary, so if you're coming in the morning, it was really easy to just come down, check on the critical alerts, make sure we're still good and nothing's on fire. From there, we can do things like cluster inventory. check the overall cluster, check the hard disk drives used, the SSDs used, the different tiers of the Isilon nodes. So we have more performant nodes, less performant nodes, but bigger nodes that can store more data. We can make sure that auto balancing is working across those. We can also check multiple access zones, so we can add multi-tenancy to connections of the Isilon, as well as checking on the different licensing details of the Isilon itself. We'll skip over node details for the sake of time, but again, it dives in a little bit deeper of the node itself. We can look at protocol details as well. So Isilon can handle multiple protocols. It can handle HTTP, NFS, SMB, CIFS, or my personal favorite, it can handle HDFS as a protocol. So if you have a Hadoop environment, you can actually virtualize the HDFS data store on the Isilon itself and just have it serve up the same data via HDFS to its worker nodes. So you could have a Isilon having multiple uses for different application use cases across your environment. We can look at file system performance as well, so not just cluster performance, but file system of the Isilon itself over time. So we can see whether it was a lookup or a set attribute or a write across multiple nodes. And again, all of these you can click into using that standard eyeglass and modify these searches to your enterprise's needs. Okay, file system cache performance as well. Talked about that middle layer of cache where you want to be able to have the data served up to that cache and read and write the data from the cache itself, not having it go all the way to the disk. We can check the health of that. As well as what we can do is check the file system audit. So not only can you monitor the Isilon as a cluster in and of itself, but you can monitor the Isilon file system. So you can see like why Debbie in accounting is accessing Frank in HR's folder 4,000 times in the last 3 minutes. Something's probably wrong, right? So what you're able to do then is see top access files. See maybe a file that blew up overnight. We should probably look into that and make sure that there's not an issue there. We can also look at the top clients, the top offenders, who's doing the most work on the Isilon and investigate from there, or look at the top failed reasons from there. And what's really great about this is that you care about this as an Isilon and a storage administrator, but your security team also cares about the same data, and it's all living within the same environment. So it's not being stored twice. It's not having to be moved across the network twice. It's all living within there, and it's all great within Splunk. Right? You can also do things like see the last audit log search facility. So this is the data coming in and whether or not it was successful or failed based upon what kind of request it was. And then you can also do the search from within it, within Splunk as well. So those were just two of the apps that we have. We have two other apps as well. We have an all-flash platform. It's not just all-flash, but we're big fans of the all-flash part of it called VMAX. It's our tier 1 block storage provider. And then we also have VNX, which is what we managed quite a bit of when I was a customer. We're working on a few other apps as well, just for different products, but we also have a team of resources here who can help provide demos as well, either virtually on-site or even at the booth here in the next little bit. With the mentioning of that team, we creatively called ourselves the Dell EMC Splunk Ninjas, because we're not that creative. But we are trained by Splunk, so we all have taken Splunk training, some more than others. But we're also Splunk architecture. We like to pride ourselves in Splunk architecture experts. So we're staying on top of the current trends and making sure that we have solutions for you as customers. We're also Dell EMC portfolio experts. So it's our day job to talk infrastructure. So we can go very deep in the hardware in and of itself, but also provide some expertise around the application layer to make sure that you have a good union of application and infrastructure. It's not just app plus infra, hope for happiness, but we can provide a full solution around that. We try and stay on top of best practices, so making sure that simple things like turning off caching, our auto tiering is happening on storage arrays, but making sure that your app administrators and your infrastructure administrators are staying on top of the best practices. We're also available across the globe. I think the only continent we're not on is Antarctica. Nobody really seems to want to take that job rec. If you are interested in having us size up your environment, take a look at your environment, maybe you want to dive deep on a few different products, or you have a specific use case or scenario or issue you want to chat about, either your Dell EMC rep or we're all right here and happy to chat. Are there any questions at all? Yeah.
So we've got a couple of VMAXs.
Yeah.
I'm just wondering, what's for the application, what's the daily ingestion rate?
Yeah. So his question was, he has a few different VMAXs and he wanted to know the daily ingestion rate for Splunk. It's going to depend, and that's an unfortunate answer, because it depends on how, yeah, and it's the size of the VMAX, how chatty is the VMAX, right? Because the more useful it is, or the more used it is, the chattier it is. We're seeing no more than 5 gigs a day. Okay, so it's not going to be like hundreds, but it's going to be in the 5 to 10, I would say, to stay conservative. What's that?
It's 200 to 300 megabytes per day per engine.
200 to 300 megabytes per day per engine. So if you have a larger one, more. If smaller, less. And again, we can chat later and help get that narrowed down. Yeah, if there's not any other questions, please don't forget to rate the session. We'd like to know how we're doing and see what we can do to help further.